Determine the values of x for which mod x over x minus 2 is greater than or equal to 3. Again, various ways that you could go about this one. We know that mod of 3 is 3. We know that mod of negative 3 is 3. So if we're going to consider the case where mod x over x minus 2 is equal to 3 to find the key values here, then what we could do is say, well, that's x over x minus 2 is equal to 3, or x over x minus 2 is equal to negative 3. I refer you to what I said up here. So this one is x is equal to 3x minus 2, and this one is x is equal to negative 3x minus 2. Let's work with the one on the left. X is equal to 3x take away 6. That would give me 2x equals 6, and therefore x is equal to 3. On the other side, I've got x is equal to negative 3x plus 6, which gives me 4x equals 6. So x is going to be 3 on 2. We could then either try some sketch graphing, or we could look at a number line and put our key values of 3 over 2 and 3 on the number line, and then consider some values, such as, if we're on the left, we could try 0. So what happens with 0? We'd have 0 is greater than or equal to 3. That is not true, so we're not in there. We could go somewhere in between here, but of course we can't choose 2. We'll come back to that. What about choosing something like 5 over 2? Then what we would have is 5 over 2 over 5 over 2 take 2. So that's 5 over 2 divided by a half, which is equal to 5. And that is more than 3, so it works in here. Of course, it doesn't work at 2 because of the denominator. And then try a value over here like 4. So that would give me 4 over 2, which is equal to 2, which is less than 3. So not in there. So that would suggest that what we want is everything in this region except 2. So we could say that x is more than 3 over 2. Was it greater than or equal to? It was. So that one's that. But less than 2. And then we could have x is more than 2 and less than or equal to 3. Let's try something different. I'm not going to go through all the different methods. Let's think about doing this and then saying, well, let's consider mod x is equal to 3 mod x minus 2 and square both sides. X squared is going to be 9 x minus 2 squared. So x squared is going to be 9 lots of x squared minus 4x plus 4. So x squared is going to be 9x squared minus 36x plus 36. And bringing the x squared over would give me 8x squared minus 36x plus 36 is equal to 0. Divide through by 4, 2x squared minus 9x plus 9 is equal to 0. That would give me 2x take away 3, x take away 3 equals 0. And so x is equal to 3 over 2, or x equals 3, as we found before. And then you could investigate that as we did before, using a number line, and of course you need to take into account that we can't have the value 2, But other than that, we could be anywhere in here, or we might be in this region going on forever down there, or this region going on forever down that way. And you can just test each region. Or you could try sketching x over x minus 2. And I'll do that very quickly. So that would have its asymptote at x equals 2. The horizontal asymptote would be y equals 1 for that one, because x divided by x is 1. And I think it is going to be here and here. And then we would have the y equals 3 would go on there like so. And then think about the fact it's the modulus graph. So this bit would stay the same. And this one would reflect up from there. And you've already found the intersections, and you can see where it's going to be above the y equals 3 line that we put on there.